Hello guys, welcome back. Today I will share about a really interesting um, overview of sequences that I have learned myself when I learned sequence and series over all these years, and I have taught a lot of students about sequences. Um, the overview will not take so much long, but the reason is that it's very organized, and you will understand why we are learning what to learn in sequences and exactly what to learn. Okay, there's a there's a distinct relationship between what should be taught and how it should be learned. And my role as a teacher is to share that to you. Okay, so this is the purpose of this video. So understand it's what a sequence. A sequence is nothing but a function from a natural number set to real number set. Okay, and we denote it by f of 1, where f of 1 goes, where f of 2 goes, dot dot dot, right? And we represented it by a1, a2, like this, and this becomes a sequence an. Here you can write as f of n. So what we are interested in the sequence, in which part of the sequence we are really interested in, what we are looking forward to learn in a sequence. The goal. The goal is to understand the long-term behavior of f of n, where the sequence is going in long-term format. Like it doesn't matter whether you like start like this and it goes like this to this. It doesn't matter uh it can do like this also. But essentially both are going to zero or towards some value. So the reason is that a learning sequence is that we are interested in long-term behavior. This is a very important point. A long-term behavior. Now, as we know this, the first part of our learning is based on um, the first part of learning is based on one very crucial thing. So understanding long-term behavior, which is defined as convergence or limit. Simple stuff. So our first, you know, uh, knowledge base should be based on what is the definition of convergence and the corresponding, so that the students learn it. The definition of convergence in terms of epsilon and definition of epsilon, okay, which is very important concept in mathematically proving the convergence of sequences. So this is very important. So we spend quite a amount of time to learn understand this. But understand our goal is to find long-term behavior, which is to find two things: whether limit exists or not, uh if yes, if yes, then what is it? What is the limit? If no, what's really happening? Like what's really happening under the hood, right? So briefly, we can distribute these two things into, we'll see, based on from the exam perspective and learning perspective both, like from problem solving perspective and understanding perspective. Problem solving, one is problem solving perspective and one is concept perspective, which we also call as behavior. So our whole course of sequences is divided into two aspects, which is a part of the mathematics full course for IDMMS and ISIM stat. So the problem solving and the concepts of behavior are based on the two different lines of approach. So let me tell you about the concepts and behavior. So what is the concept of behavior? Understanding the concepts behind the limits. So we understand the definition is one of them. So after the definition comes, if if a sequence converges, what are the properties of it, right? Like what is really happening it to converge, what is actually making a sequence converge. For example, a monotone and bounded, if you let's say if you have a sequence, let's say you assume that sequence is a step. Let's say sequence is a step in you're taking, you know the height is the length, the amount of length you're covering in one, the length of the sequence, the value of the sequence. So if you're taking a sequence like this, So and if it's increasing, it's like this, and you know the sequence is increasing and it has an upper bound. Okay, it never goes beyond the upper bound. So of course you can understand that as n goes to infinity, it will converge somewhere. So essentially, it's understanding that the theoretical aspect of y sequence converges. Like something is called monotone convergence theorem. Like if its sequence is monotonic, increasing or decreasing, and it's like monotone bounded theorem. Okay, monotone increasing or decreasing and it's bounded, then it should converge. And similarly, we have Bolzano stress. Not Bolzano stress. So coming back to after monotone bounded theorem, we understand that what happens if a sequence converges, like what happens to its subsequences. So we understand a bit about the relationship subsequence and actual sequence, the relationship between subsequence and actual sequence. Okay, monotone bounded theorem. And then we understand that what happens uh, if a sequence does not converge, what happens to its subsequence. Okay, what happens to subsequence. And we learn that if a sequence doesn't converge, so we'll see that a sequence doesn't converge only if its subsequence converges to various limits out there. It's erratic. So the natural question comes that what are the possible limits the subsequence converges? So that's why the concept comes limit inferior and lim sup. Okay, which tells you what happens there. And so we are going to the depth of the behavior. Like if a sequence converges, what's causing it to converge? Okay. If a sequence is not converging, okay, if a sequence is not converging, why it's not converging? What's the behavior of a subsequence? So we understood that the subsequential behavior is very important for a sequence to converge. So a sequence converges if and only if it's all subsequence converge to the same limit. So therefore, sequential convergence based on a subsequence convergence. So we'll understand these concepts of the relationship of why a sequence converges, why a sequence doesn't converge. If a sequence doesn't converge, what happens? Okay, all these things. And also we'll see in the behavior understanding and there are also other many minute concepts I need to know. If a sequence converges, the limit is unique, and all the other things, right? So it's about understanding when a sequence converges, what happens when a sequence doesn't converge, what happens, etc., etc., etc. Also, there's another concept called Cauchy sequence. For example, understand we will see in a sequence definition, we need the definition of a limit. Like we need a limit. Okay, we need to define a limit, and then based on that limit, we need to define the convergence. But often what happens that we may not know the limit. Then how to show the convergence of a sequence? So we'll see Cauchy sequence and convergence sequence are very similar. So it's an interchangeable definition in R. Okay. So this is a very interesting idea that we say that why are like understanding why limit exists or not. It's like doing operating on the sequence and understanding what's under the hood, how it's working, which sequence is converging, which sequence is not converging. Like the why, the behavior, this concept that's happened. On the other hand side, the problem solving is very important. It's understanding that it's computing. It's a computational way of showing that sequence converges or not. Okay. So we will see there are two aspects. Two ways of a sequence can be defined. Essentially, the sequence is a function, right? This f of n. So the function can be defined in two ways. It's absolute format. Absolute means it's given that f of n is equal to, let's say, sine n by n. But it can also be given in form of recurrence relation. Let's say given that xn is equal to xn minus 1 by 2 plus 1 by xn minus 1 with other conditions, right? So we'll see how to deal with each of these things, and to find the limit, whether the limit exists or not. So we ask two questions: limit exists, same question, limit exists or not. In this same type of questions, we will see that there are various approaches to each of this. We will teach you all of this, and the basic idea is this: we will understand that the fundamental idea is this is already, if you have learned, it's called the algebra of limits. So we find out a basic algebra of so it's knowledge plus algebra. So we find out a very concrete set of sequences which always converges. For example, sine x by x goes to 0, it's 1, like all these basic things. But yeah, we need to prove it by mathematically, but essentially it's knowledge base of limits. You know that these limits converge, and you know the limit. And you add the algebra of limits, that addition of two limits converges to the addition of the limits, and all these things. Algebra of limits, how the limits interact with each other, how sequences interact with each other. This is one way to do that. Another way to do that, there are various things. There are various things like squeeze theorem. Okay, so we use two known sequences and we bound it. It's unknown sequence, let's say star of n, and we bound it by some known sequences an and bn, and we know the behavior of it. So we know the behavior of this two. From that, we can understand the behavior of this one. We can show it's bounded, or we can show the limit exists. So these are called squeeze theorem. So they're also like the knowledge algebra of limits and squeeze theorem connects together. So essentially, it's using the basic idea is using known knowledge. Known knowledge is kind of, it's the same thing. It's known stuff, known information to find new one, right? So this is one such thing. The other such thing is also we use MCT. We use this monotone MBT, like monotone bounded theorem, to show that the sequence is monotone and bounded, and we find out the corresponding limit and show it's convergent, and then we can find out the limit. So there are various also things. There's something that I personally prefer is called Bigo notation, which tells you that how a limit really um, what the limit is equivalent to, so that we can easily understand it. And this will be really useful in series, you will see. Essentially, our goal is simple. Our goal is to understand, like, there's a one problem solving behavior, understanding a problem solving, and understanding a corresponding concepts and behavior. The goal is very simple, is to make you be comfortable in own skin about this. But how to learn about sequence, how to go about, how to make a story out of a sequence, that's the whole story. So I should say this is the story of a sequence. This whole idea is about the story of a sequence, the story of understanding sequences. You see, there's a story, there's a map, there's a mapping of understanding, there's a mapping of behavior, and what happens inside that story of understanding sequences. And I hope it helps you in your learning. And I also see in the classes, I hope you understood and made your perception about sequences better. And thank you for joining. Thank you for watching the video. Stay tuned and stay blessed. I will see you in the next classes soon. Bye bye. Have a great day ahead.